Okay, hot water. That's probably the most common, especially up in the Northeast, and that's where I spent most of my career as a contractor, was in the Northeast, New Jersey primarily, along the Jersey Shore. And there is a ton of hot water heating. We always called it hot water baseboard heating, to be more specific about it. But it can be steam as well, and there, again, in the Northeast especially, there is a lot of steam heating systems. Even today, there are people putting in new steam heating systems. Not surprising, knowing how well that can heat a building. Radiant heat, where you have hot water pipes in the concrete slab that make the floors warm. All right, this is very often not the primary source of heat, but it's more like a secondary source. You see this in upscale homes in cold climates very often. They'll have a big family room and a great room adjacent to a big kitchen, and those areas will have these panels in the floor. And the real source of heat is hot air. The panels are there primarily just to make the floors warm, although they can carry the load during mild weather when it's 50, 40 degrees outside, that kind of thing. So it's something that's mostly seen in upscale homes. Okay, what you're looking at here is a cross-sectional view of, or at least a cutaway view of the most common hot water boiler you're going to find in residential work, and that's the gas-fired hot water boiler. All right, you can see the gas burners down along the bottom with the gas controls. They're calling out an insulated metal enclosure. That's called the boiler jacket. Okay, and it's nothing but a sheet metal box that's lined with anywhere from 1/2 inch to 1 inch fiberglass, much like fiberglass lining on a duct system. All right, you can see the drain. The drain would let the water out of the heat exchangers, the cast iron heat exchangers, and I'm going to show you a much better picture of that in a few slides from now. But again, the drain would just drain the sections, the cast iron sections. You see the circulating pump, the water circulating pump. The temperature and pressure controls, that would be some sort of an aquastat, A-Q-U-A, like the Latin word for water, aqua. You see the hot water outlet and inlet. They actually have them reversed there, but that's okay. You see the draft hood, and then, of course, the exhaust gases going to the flue pipe, which eventually ends up in some sort of vertical chimney. Now, this is a barometric draft hood, and this is a barometrically drafted boiler. That means that the way the hot gases from the gas burner get out of the boiler is by buoyancy, the fact that they're hotter and less dense than the air that surrounds the boiler. All right, so they go up to the flue pipe that way. You can eliminate that draft hood, and you can have a fan there, and it could be fan assisted, which would may or may not increase its efficiency depending on how the boiler was designed. Okay, but these are the basics. Those you're going to see that on any type of gas-fired hot water boiler you go to. The exception might be a company like Hydrotherm. They use pancake sections, cast iron heat exchanger sections. They're not vertical. They lay down flat on their side, if you will. Okay, but everything else is the same. The principles are all the same. All right. Let's take a look at some of the stuff we just looked at in the last slide. And the heat exchanger is most of the boiler. It takes up the greatest amount of room and certainly does a lot of the work. Now you see the big opening in the bottom left. That's where the cold water enters. The cold water is heated up and then discharges out the top. Okay, hot water rises. So the cold water enters. These sections are put together by push nipples. I'm going to show you a picture of that in a few slides. And the water circulates through there, takes the heat out of the flame, out of the flue gases, and you'll notice the projections on that heat exchanger. They're there to slow down the velocity of the exiting flue gases that are trying to rise up and go out the flue pipe and into the chimney. All right, and they're there to slow it down so they can take more heat out of the flue gases. All right, and that's all controlled by the design the manufacturer's engineers have developed for these heat exchangers. All right, that's cast iron. Very, very common. These are vertical cast iron. They can lay down flat. Like I said earlier, Hydrotherm makes those. They call them pancake sections. Here's another very common type, steel tube heat exchanger. The water runs through the inside of those tubes, and the burners, you can see the burner on the bottom, that looks like a either a gas power burner or an oil burner. I can't tell from the picture, but that heat is going to be taken off by the water in those tubes. And again, the more heat you take off, the more efficient the boiler is. They do make residential steel tube boilers, but they're not real common. Okay, mostly you'll see steel tube boilers in commercial work.